Okay, so we proceed to the third method, which is the fixed point iteration method. So we are given a function equal to 0. What we need to do is to convert to x equal to g of x. So manipulate natin si function natin and come up with an equation of x. Now, while expressing f of x is equal to 0 to x equal to g of x, we can have many different forms. Maaaring iba-iba yung pag-manipulate natin sa ating equation. Now, before we proceed to iteration, meron tayong condition for convergence. So that condition is if the absolute value of the first derivative of the manipulated function is less than 1, then we can proceed to iteration. Otherwise, we look for another formula of x. Okay? So, iterative formula natin is x sub k plus 1 equal to f of x sub k. Okay, so now let's try examples. We have example number 1, x squared minus 3x plus 1 equals 0. So, we try to convert it to x equal to g of x. So, ang gagawin natin is to transpose this one to the other side. So, magiging x squared plus 1 is equal to positive 3x. Since x lang yung gusto natin na may isolate, divide natin both sides by 3 to cancel this one. So, we are left with x is equal to x squared plus 1 over 3. Now, for the condition for convergence, before tayo mag-proceed to iteration, we get the derivative of this one. So, the derivative of f prime of x is equal to, that is 1/3 times 2x, or this is 2x all over 3. Now, given tayo ng initial value, so, x sub 0 equal to 1. Plug natin si x sub 0 dito. So, 2 times 1 over 3 is equal to 2 over 3, or in decimal, that is 0.667. And it is less than 1. So, we can proceed to iteration. Ibig sabihin, we can use this equation in our iteration. Okay. So, our iterative formula is x sub k plus 1 is equal to f of x sub k. So, at k is equal to 0, that is x sub 0. So, our x sub 1 is equal to f of x sub 0. So, this will be equal to, ayan, si 1 over 3 times x natin will be si x sub 1 equal to 1. So, 1 squared plus 1. So, this is equal to 0.667. Ito ngayon si x sub 1 natin. Now, at k equal to 1, x sub 1 natin is equal to 0.667. Now, computing for x sub 2, we have x sub 2 is equal to f of x sub 1. So, this is equal to 1 over 3 times 0.667 squared plus 1. And we get 0.482. Okay. Now, for at k equal to 2, x sub 2 natin is equal to 0.482. Computing for x sub 3, we have f of x sub 2. This is equal to 1 over 3 times 0.482 squared plus 1. And we get 0.390. And for at k equal to 3, we have x sub 3 equal to 0.390. So, computing for x sub 4, we have f of x sub 3. And this is equal to 1 over 3 times 0.390 squared plus 1. And we get 0.384. So, we can now stop there. So, that is how you solve fixed point iteration. How you use the method fixed point iteration. So, let's try another example. Same function tayo, but this time x sub 0 is equal to 2, and we need to use, we try to use another equation for x. So, let's try, eto, x squared is equal to, transpose natin itong dalawa sa kabilang side, that will be positive 3x minus 1. And in order to eliminate si square dito, kailangan natin kunin yung square root ng both sides. So, our x is equal to the square root of 3x minus 1. Now, for condition, so f prime x natin is equal to, okay, so pwede natin tong isulat into exponential fractional exponent that is equal to 3x minus 1 quantity raised to 1 half. So we apply power rule. This is equal to 1 half times 3x minus 1 times 3. Okay, so we simplify this one. F prime of x is equal to, that is equal to 3 over 2 times 3x minus 1. Okay? And we try to plug Cx is equal to 2. So at x sub 0 equal to 2, then this is equal to 3 over 2 times 3 times 2 minus 1. And we will get 0.671. And we can proceed to iteration. Okay? So we stop at x sub 4 din, gaya kanina sa una. So at k equal to 0, we have x sub 0 equal to 2. So x sub 1 natin is equal to f of x sub 0. So this will be equal to, ito yung gagamitin natin, 3 over 2 times 3 times 2 minus 1. So this is equal to 3x minus 1. Now, if we plug C2 dito, we will get a value of 2.236. Now, for at k is equal to 1, we have x sub 1 equal to 2.236. Then, we compute for x sub 2, that is equal to f of x sub 1. And 3 over 2 times 3x minus 1 is equal to, if we plug si x sub 1 dito sa function natin, we will get x sub 2 equal to 2.389. Ayan. So, at k equal to 2, x sub 2 natin will be equal to 2.389. So, computing for x sub 3, we have f of x sub 2, and this is equal to 3 over 2 times 3x minus 1. Substitute 2.389 dito sa function natin. We will have 2.483. And at k equal to 3, x sub 3 is equal to 2.483. We have x sub 4 is equal to f of x sub 3. So, this is equal to 3 over 2 times 3x minus 1. Plug natin si 2.483 dito sa function, and we will have 2.539. Okay? So, that is example number 2 for fixed iteration method. Now, let's try example number 3. F of x is equal to 5x cubed minus 10x plus 3, and x sub 0 is equal to 0.1. So, we try to have to convert this to x equal to g of x. So, this is 5x cubed. So, try natin i-transpose si 10x sa kabilang side. So, that will be positive 10x equal to 5x cubed plus 3. We divide both sides by 10. So, we have x is equal to 5x cubed plus 3 over 10. Now, for convergence, for the condition, we check if the first derivative of our function is less than 1. So, what is the derivative of our function? That is equal to 1 over 10 times 15x squared. And this is equal to, of course, this will cancel. Tapos magiging 2. That is 3x squared all over 2. Okay? And at x sub 0 equal to 0.01, then 3 times 0.01 squared over 2, f prime of x is equal to, if we are going to compute this on our calculators, that is equal to 0.015. And this is less than 1. So, we proceed to iteration. So, at k equal to 0, x sub 0 is equal to 0.01. So, x sub 1 natin is equal to f of x sub 0, and that is equal to 5x cubed plus 3 over 10 is equal to, if we are going to plug 0.01 dito sa x natin, we will get 0.301. At k equal to 1, we have x sub 1 equal to 0.301. So, yung x sub 2 natin will be f of x sub 1, and this is equal to 5x cubed plus 3 all over 10. And we plug si 0.301 sa function natin, and this will be equal to 0.314. Now, for at k equal to 2, x sub 2 natin is equal to 0.314. Computing for x sub 3, we have f of x sub 2, that is 5x cubed plus 3 all over 10. If we plug x sub 2 dito sa function natin, we will get 0.315. So, we stop there kasi yung interval na niya is maliit na. So, that is how you solve a system of nonlinear equation using the fixed point iteration method.